Hi everyone. So I don't know if you all have this issue, but we have to run a dehumidifier in our basement in order to keep the humidity down enough that things don't get moldy. And so about 7 years or so ago, we bought this Ivation unit that worked pretty well for the most part. It in freestanding mode, it actually has a tendency to leak. Not all of the water would end up in the bucket and it would just pool around it. But when you connect the drain hose to the back, then it worked okay. So I guess that was kind of a win. This was one of the higher rated units on Amazon at the time. But then just not even 2 years ago, we found out that the carbon dioxide level in our home was kind of high. And so what do you do to fix that? Well, you install an energy recovery ventilator, which exchanges air with the outside world. And it tries to balance out the temperature and humidity so you aren't losing all of your heating and cooling effect on the house, and so that your inside humidity doesn't turn into the outside humidity. But it can only do such a good job. And so when our basement started getting humid again, we thought maybe it was the added load from that ventilator that was causing the humidity to increase beyond levels that this single unit could provide. Maybe kind of a lesson in messing with the equilibrium of the universe. But we had carbon dioxide levels that were too high and we had to do something about it. And so the only way we could do something about that was to get that ventilator installed. It was probably a side effect of all that energy efficient sealing that we had done around here. So you spend a bunch of money getting all of the gaps sealed so you don't lose energy, and then you've sealed the house so tight that it can't breathe anymore, and you start building up carbon dioxide. And I assume it's just from the humans and cats breathing in the house, but maybe there's carbon dioxide dissolved in our water coming in through the plumbing system. I don't really know. I wasn't able to find a way to test for that. But anyway, when this unit stopped dehumidifying well enough, we bought another one. And so this unit solved our problem for, I don't know, a year, year and a half, not very long really. And then we got to the point where both of these units turned on, set to run full blast. Our basement was still like 60% humidity. And so maybe this one was on its way out at the time we got this one. Maybe it wasn't really that big a deal that we got an energy recovery ventilator. But now both of them are not working acceptably. They both measured 60% humidity, so they knew the humidity was too high, but they weren't really doing much of anything about it. And from monitoring their energy usage, it seemed like the compressors inside of them were kicking on sometimes, but not all the time. Like it would only sometimes be running at 500 watts, and most of the time it would be running at more like 75 watts. So I suspect it's having trouble, they're both having trouble starting up their compressor. And so I'm thinking, if we're very lucky, that very much like the heat pump for air conditioning and heating a house, we might find that there's just a capacitor inside these things that have gone bad. And I have two dehumidifiers here, so you would think we'd be able to fix one of them, right? Well, let's find out. And so starting with the V-Remy, this thing is absolutely riddled with screws. There were two holding it on the bottom, one here and one here. And then you kind of lift the panel up and pry it off because it's got support holds that you can't see because you don't have x-ray vision until you get it off, but kind of up and off seems to get that off. And then you don't see a whole lot of anything, making you think you wasted your energy removing that panel, but there's a whole bunch of screws inside the crevices here that you have to unscrew in order to get the back panel off, which is this part. And I still don't know if it would have been easier to leave the gray piece attached to the white piece, but some of the screws secure the gray piece into the frame, and of course you can't tell which are which. It looks like the interior two screws were holding it to the white back housing, and the outer two are holding the gray to the frame. So do with that knowledge what you will. But there were screws here that were holding the white back panel to that gray. And don't miss the little screws down here that are on both sides that are holding the gray part to the frame. So that was fun. And now I still don't entirely know what I'm looking at in here. This big thing I imagine is the compressor. This looks like a housing that'll have something inside of it. And I think this is just tubing with insulation on it over here. So if I'm looking for a compressor, you see the power cable, this is the power cable going into here. And other wires. So I'm thinking the electronics are in here. And hopefully that's where any capacitor might be. And I stand corrected. So just after removing that one panel, there was this doohickey here that I was a little afraid to mess with, but you can just pull it off, and lo and behold, we have a capacitor. So you don't have to disassemble the entire thing like a lunatic. You can just unscrew those two screws that were holding this panel on, and then pull this cover off, and you have a capacitor. So let's test it out and see if it works. And capacitors can deliver a nasty shock, so you should always short the connectors together before touching anything, just to make sure. You'd like to think that these days they'd have a bleed resistor in there so you don't get shocked, but anytime you see a capacitor, like a large cylinder like this, be it in a heat pump or a dehumidifier or a microwave oven, be careful, because they can store quite a bit of energy even after the unit has been unplugged. And this unit is labeled as a 40 microfarad capacitor, and I'm measuring it at 39, so in this case there is not a problem with the capacitor. Whatever is causing trouble is something else. Maybe the refrigerant leaked and the pressure isn't where it should be. I don't have the equipment to measure that. But that's probably the extent of a problem that I would have been able to diagnose. I guess I could always open up that electrical box and see if anything looks like it obviously exploded. But if it's getting power and the capacitor is good, that's usually about the extent of my troubleshooting capability on a compressor. And for the record, here's what's inside that electronics box. There is a control board with what looks like a transformer and a bunch of wires leading up to the control panel. And I think those look like relays down there. Nothing has obviously exploded or anything, and the control panel up top was working fine. Like I said, it measured 60% humidity. It just didn't seem to successfully do anything about it, so I don't really have any reason. I guess one of the relays could have gone bad, but we're getting into some fairly messy diagnosis. I mean, for that matter, there's little capacitors in here that could have failed too, but we're supposed to be past that era where capacitors are failing left and right, at least the little ones. So I don't know. Maybe I should buy the equipment to measure the refrigerant pressure. I don't even know what refrigerant this takes. R410A. Can you still get that? I don't know. Manufactured in 2020. I got this one either used or I think open box they called it. So I don't know if the person who originally bought it decided it didn't work as well as they liked, but I saw nothing wrong with it for the first year. It got the job done. So I think that's a failure to fix the VREMI, and now we can move on to Ivation. So this one had 4 different screws holding the panel on. There were 2 on the bottom, but also to turn it around and get inside those crevices on top to get 1 on each side there. So 4 screws total. And then when I get it off, I don't see the capacitor here. So they laid this one out differently. And I'm probably going to have to get the back panel off, so that's fun. So this one was marginally less painful because the back and side panels are one piece instead of this one, which has the gray separate piece down the middle. But there are still a whole bunch of screws. You have to kind of yank this out. It was just pushed inside of this tube here. Hopefully it can go back in without leaking if we're able to fix this thing. But I imagine this is the capacitor over here. So let me put my gloves back on and we'll see if we can test it. Usually it's good to use needle nose pliers so you don't tear these connectors apart. So I don't know if you can see it too well, but the screw that is used to tighten around the capacitor to hold it in place is way back there. And look at the angle that thing's at. Like, the screwdriver would have to be like this, and there's all this in the way. So I have to actually remove where that mounts to the black plate, which is annoying. Who designed it? Now that it's removed and I can read the label on the thing, it says 45 microfarads and I measure 44. So once again, not a problem with the capacitor. Maybe that's why I don't see other videos on YouTube telling you to change your capacitor. So once again, I'm left with a mystery. Maybe the refrigerant has leaked out. This one also uses R410A, and I'm not sure where exactly you're supposed to measure the pressure, but I don't have the right gauge for that. So anyway, I hope you enjoyed your look inside the standard residential consumer grade dehumidifiers that break every few years. And this time around I have purchased a Midea dehumidifier that I got from Walmart because Consumer Reports says that that's one of the brands that's more reliable in their experience. There are a bunch of them, and Midea was not the very top rated, but this was what I could get at Walmart same day, so I went with that. So fingers crossed that this one lasts, because I haven't got a clue how to fix either of these two. Hope you enjoyed yet another misadventure in electronics. If you did, please give this video a thumbs up. Thanks.